Good morning students, welcome to the next lecture on ground improvement techniques. So until the last class we have completed half of the syllabus, that is in situ densification of granular soils. So up to the previous class we have completed the densification of granular soils. From today onwards we are going to discuss in situ densification of cohesive soils. So what is the example for cohesive soils? The best cohesive soils are clay and silt. Okay, up to the previous class we discussed with sand and gravel. What are the various methods to densify the sand and gravel? Okay, this one is completed, which includes vibroflotation, dynamic compaction and stone columns. Those methods are completed. So the first method to densify the cohesive soils, that is clay and silt, are preloading. Second one is sand drains. Third one is wick drains. Okay, so the first one is preloading. Okay, in the name itself it indicates we are going to apply the load before the construction of the structure, whether the structure may be a building or a bridge or any other one. Okay, we are applying the load before the construction. Okay, what is the type of load that we are applying? Generally we can apply soil or sandbags or gunny bags or whether the waste material. Okay, whatever the material we apply on the site before the construction of original structure, that is known as preloading. Okay, so why we need to apply the load in advance before the construction of original structure? That is to reduce the settlement. Okay, so let's start from the first one, preloading. Preloading is a surcharging. Okay, preloading is different and surcharging is different. For example, the original structure that we are going to construct is which applies a load of 100 kilonewton on the soil. This is the load from the original structure. Before the original structure we are applying about 120 to 150 kilonewton load on the soil. Okay, this is known as preload. This is the load coming from the original structure. Before the original structure we are applying excessive load on the soil, that is about 120 to 150 kilonewtons. Okay, the load more than the original load is known as surcharging. Okay, here we are applying 20 kilonewton excess load. Okay, that 20 kilonewton is known as surcharge load. Or else if we apply 150 kilonewtons, which is 50 kilonewton more than the original structure load, so this excessive load, that 50 kilonewton, is known as surcharge load. Okay, so preloading is surcharging the ground with a uniformly distributed load. The original structure may not be a uniformly distributed load. Okay, that may be a varying load, but here we are applying uniformly distributed load before the construction of structure, such as maybe a building or maybe an embankment or maybe a runway. Okay, next, what is the purpose? So why we need to apply the preloading? So as we already discussed, to take up the settlements. For example, we are not applying any preload. We are directly doing the construction work. We are directly constructed a building on the soil. Because of the building load, the soil settles down. Okay, which may lead to the settlement of building. So that's why in order to prevent the settlement of original building, what we are doing? We are applying a preloading. Because of this loading, all the settlements are already occurred. So after we construct the original building, there is no settlements. So that's the concept. In order to prevent the settlements when the original load is constructed, we are applying preloading on the soil. So this is the diagrammatic representation. This is our site. What we are doing? We are applying a preload. See, this portion is known as surcharge. Okay, what is preload? The original weight of the structure. For example, the original weight of building is 100 kilonewtons. This preload is known as 100 kilonewtons. The value of the preload. Okay, this is 100 kilonewtons. Whatever the excessive, other than 100 kilonewtons, whatever the excessive load that we are applying is a surcharge load. Okay, so for example, we apply 200 kilonewtons, total 200 kilonewtons load Out of this 200, 100 kilonewton is known as preload, other 100 kilonewton is known as surcharge load. Okay, the excessive load other than the original load is known as surcharge load. So what is happening here? When we apply a preload with surcharge on a side, see these downward arrows. Soil is a three-phase system. It contains solid particles, water and air particles. When we apply the surcharge load, all the solid particles settles downwards. Only the solid particles. Okay. In between the solid particles there is some water molecules. So all the water molecules tries to move in the upward direction. Okay. The downward movement is the movement of solid particles. The upward movement is the movement of water. Okay. The upward movement of water through the soil is known as pore water pressure. Okay. If the water passes in a upward direction between the voids of soil, then it is known as pore water pressure. This method is suitable only for cohesive soils. Why? So let's see what is the suitability of soil, what is the soil and which method is suitable. What are the various type of soils? We have generally 4 type of soils: gravel, sand, silt and clay. These 4 are the general type of soil based on grain size. Okay, let's see what are the various ground improvement technique methods that we have. The first one is we can apply vibration forces. We can apply vibrations. So by using vibrations we can densify the soil. We also apply impact forces. Next one is static. Okay, these are the general 3 type of loads that we use to densify the soil. The first one is vibrations. Vibration force. By using the vibrations, we can only densify the granular soils. We cannot densify silt and clay using vibrations, right? So, in situ densification of granular soils. These 2 are coming under granular soils. So, what we use to densify these 2 soils? The first one is vibroflotation. In that method, we use vibration forces only. The second one is dynamic compaction. So, there we use impact forces. Okay, in order to densify the gravel and sand, vibrations and impact are the best suitable. We cannot use the static forces like preloading. Okay, we cannot just apply the load on a soil such that gravel and sand cannot densify. Okay, so these 2 methods are useful to densify gravel and sand. Okay, so the static methods, what are the static methods? Like dewatering techniques or electroosmosis or like preloading, and 2 more methods that we are going to learn, that is sand drain and wick drain. These all are coming under static methods. We are not applying any impact, we are not applying any vibrations. We are just placing a static load on the structure. Okay, by using the static loads we can densify silt and clay, mostly clay. Okay, by using static we can also densify the silt also. So why I am explaining all these? Just to give a clear idea. If the soil present in our site is whether silt or clay, we need to apply the static loads. If the soil available in our site is whether gravel or sand, then we need to apply vibration or impact forces. Okay, we cannot apply the static forces. Okay. So here we are applying static force because the soil available is a cohesive soil, that is clay. Okay. Coming to the suitability. So preloading is suitable for compressible soils. What is compressibility? Compressibility is a property of soil which changes its volume under the action of compressive loads. So let's take a soil. We consider a 1 cubic meter of soil. And what we are applying? The only force we are applying is compressive force. Okay. Due to the compressive force, its volume may changes. Okay. So the change in volume of soil under compressive loads only, not the tensile forces or not the shear stresses. Under the action of compressive forces only, if the soil changes its volume, then it is known as compressibility. What is the high compressible soil? High compressible soils are examples. For example, the example for compressible soils are clay. If you apply the compressive forces on the clay, its volume changes rapidly. Okay. The second one is organic soils. Organic soils means the soils formed due to the decomposition of vegetable matter. Okay, that may be due to the decomposition of trees or decomposition of animals, like that. Whether any decomposable organic matter forms organic soils. Okay, these two soils are highly compressible soils. Okay, peat is also another one. Peat is a combination of organic soil and inorganic soil. Okay, that is known as peat. Peat is a highly organic soil. These three types of soils are known as compressible soils. So by using preload, we can settle these three types of soils. Okay. So there is also one more question. Clay is a compressible soil, but clay is also occur shrinkage and swelling. We already discussed about it in the first class. What is shrinkage? What is swelling? And compare these two with the compressibility. What is the difference between these three terms? Right? Shrinkage. Shrinkage means the reduction in volume. Swelling means the increase in volume. Okay? Compressibility means the change in volume, whether it is increasing or decreasing. So what is the difference? Swelling and shrinkage are due to water. We are not applying any external loads. Only due to the internal actions, swelling and shrinkage will occur. But whereas compressibility means we need to apply the external compressive force. Okay. If the water is added to the clay, then its volume increases. We are not applying any loads. We are just adding the water content. If you remove the water content from the clay, then its volume decreases. Okay. Here in these two parameters, we are not applying any external forces. But whereas in compressibility, we are adding some external forces. Okay, that is the difference. Now coming to the next one, saturated clay and silt. We already discussed static methods can be applicable for clay and silt, not applicable for gravel and sand. So it is suitable for saturated clay and silt also. It is not a natural sand, natural clay and silt. It is a saturated clay and silt. So what is the meaning saturation? Saturation means it contains water just enough to fill all the air voids. Okay. For example, take a soil. It has a solid particles and it also has some air voids, right? Say these triangular portions are air voids. Let's imagine. These triangle portions are, we are assuming as air voids. So all these air voids are filled with water. We add some water so that all these air voids are filled with water. So that condition is known as saturation condition. Okay, all the air voids are filled with water molecules. It contains zero air voids. That is known as saturated clay and silt. So the third one is organic soils. Okay, compressible soils. Organic soil is one of the compressible soil. So we can apply the preloading method to the organic soils also. There are so many organic soils. For example, peat is a organic soil. Next one is a humus. Okay, these two are organic soils. There are some other soils also. For all such type of soils, we can apply the preloading method. Okay. The next one is coming to the advantages. So what are the various advantages of using this preloading technique? Okay. The first one is almost free of noise. What we are doing, this is the available site for us. We are going to construct a building on the soil. What we are doing, we are just placing some excess amount of soil. Okay, we are just placing soil. We are not creating any noise. So it is almost noise free. The second one is no vibration problems like other techniques. Okay, previously we learned about vibroflotation, dynamic compaction and stone columns. Those three methods are based on the principle of vibration forces only. Okay, in those three methods, the vibration forces only densifying the soil. But here we are not using any vibration forces. We are just placing the soil on the surface. So if the vibration forces are developed, then it may damage the surrounding structures. Okay, so we don't have any such problems with the preloading method. The third one is cost effective. Absolutely, the cost for laying a soil on a surface is very low. We don't need to give more cost. Okay. The next one is reduce settlement of soil after construction. This is the main purpose why we are doing preloading, is to reduce the settlement of soil after the construction of the structure. Okay, that is our main objective. Coming to the disadvantages. So obviously it has some of the disadvantages. It takes more time. So just imagine if you place a preloading on a soil. For example, here we have a water molecule. I have applied the preload. So what is the time taken by the water molecule to reach the top of the soil? Okay, it will take so much of time. In this in situ densification of cohesive methods, we always use a word consolidation. Okay, in the previous methods we use compacting and densifying, but here we need to use a word called consolidation. Okay, consolidation means long term effect, whereas compaction means immediate effect. In the previous three methods, we are compacting the soil, which means when we apply the vibration forces, immediately all the air and water molecules are removing. Okay, immediately the soil is densifying. That process is known as compaction. From here onwards, we never use a word called compaction. We only use a word called consolidation. Okay. So this is a soil medium. So what is the time taken by the soil water molecule to escape through all the soil particles? This all is a soil. So it takes so much of time for this particle to reach the ground surface. So that is one of the main disadvantages. The second disadvantage is rate of consolidation. Always use the word called consolidation. Rate of consolidation depends upon time. Okay, for example, we keep the preloading for 3 months. Then the rate of consolidation is something. If we increase the time of preloading, then the rate of consolidation will also increase. Okay, it is consolidation is purely depending on time for which we are placing a preload on the surface. Okay, we cannot place the preload for longer time because we need to do the construction work, right? So obviously the preloading time is generally very less. So the rate of consolidation is also less. So in order to overcome these two disadvantages, there is one more method is developed, that is sand drains. Okay, what are the disadvantages? It takes more time. Rate of consolidation depends on time. These two are related to time consuming only. So to reduce the time, we develop a sand drain method. It is very similar to the preloading. So what we are implementing? The implementations are, we are placing a sand drain here. This is a sand drain. Okay, drain means what? Some carrying medium. Okay, here the sand is carrying the water. Here we have a water molecule. So the water molecule first enters the soil drain, then it can easily move to the top. Why? The permeability of sand is very high. Okay, permeability means the ability of material to allow the water to pass through it. If it allows the water easily, its permeability is very high. If it does not allow the water to pass, then its permeability is very less. We call clay as impermeable medium. Clay is also known as impermeable. It does not allow the water to pass through it. Okay, so that is the main problem. If the soil is impermeable, then how the water molecule reaches to the top? So that's the main problem. So that's why we are providing these sand drains. See these arrow symbols. See this. What is this indicating? These are placed towards the sand drain. First of all, the water molecule enter the sand drain. Then it moves to the top very easily. It doesn't take that much of time. Okay. Again, by joining all these sand drains, there is a sand blanket. This is known as sand blanket. This is known as sand blanket. Taking the water to the surface is one step. The second step is we need to drain the water away from the site. So that's why the drainage blanket collect all the water from the drains and discharge to the discharge away from the site. Okay. So this is a preloading. This is a horizontal drain. Okay. This is placed in the horizontal direction, right? So that's why it is known as horizontal drain. Okay. Drain means it's a water carrying mechanism. It may be made of sand, and it may be made of gravel or anything else. So this is the mechanism. In order to reduce the time taken by the soil water molecule to reach the top, we are implementing these sand drains. Okay, also known as vertical drains. See, this is the soft ground before the laying of sand drains. After laying the sand drains, all these green marks, all this green area is improved ground. Okay, we are improving its properties. So let's see point by point. The first one is soil drains is a process of radial consolidation. Radial means horizontal and vertical. Radial consolidation which increases rate of drainage. Rate of drainage or rate of consolidation. Drainage means the water is coming out of the soil. That is the another name of consolidation. So it increases the rate of drainage in the embankment by driving casing. What is a casing? Casing means a hollow medium. A hollow circular pipe is first driven into the soil. Okay, the soil inside the casing is washed out by using various methods, whether by using a water jets or by using any other method. We remove the soil inside the casing. Okay, what we are doing inside the casing, we are pouring the sand. Again, the casing is lifted to the top, so there only a sand is left. Okay, we are driving a casing into the embankment and making vertical boreholes. So here they are using boreholes to remove the soil inside the casing. Casing is a hollow circular pipe. Generally we use steel pipes. Okay, a steel hollow circular pipe is known as casing. First we driven the casing into the soil by using various methods, by impacting or by using any method. We first drive the casing into the soil. Then by using the vertical boreholes, we are removing all the soil inside the casing. Inside the casing we are placing the sand. Okay, that is the method. Next, the holes are backfilled with suitable grade of sand. See, once we remove all the soil inside the casing, we are backfilling with the suitable grade of sand. Next, construction process. Let's see the construction process. First of all, after the driving casing, again the driving casing is withdrawn after sand has backfilled. Once we fill the sand into the casing, what we are doing? We are just withdrawing the casing. Then a sand blanket is placed over the top of all the sand drains. Okay. See, this is the sand blanket placed over all the sand drains. Coming to the next one. What they are doing? They are accelerating the drainage process. Drainage means they are accelerating the consolidation. A surcharge load is placed on the sand blanket. Okay, we must need to place a surcharge load. Once we place the load, then only the water tries to move in the upward direction. If you do not place any surcharge load, the soil still remains in its position. It does not move to the top. The next one is the surcharge is in the form of, here they are using dumped soil. Okay, otherwise we can also use sand bags also. We need to place a load, that's it, whether it is a soil or it is a sandbags or anything. Coming to the mechanism. So how the consolidation is taking place? The first one is pore water pressure is increased. Pore water pressure means the water tries to move in the upward direction. Okay. See, this is the soil. These are the solid particles. When we apply the load on the soil, the water particles tries to move in the upward direction. Okay, that puts some pressure on the solid particles. That's why it is known as pore water pressure. Pore means voids. Water is applying pressure on the solid particles. So that's why it is known as pore water pressure by applied surcharge load in the embankment. Here what is the load? Surcharge load. That is the first point. Second one, drainage occurs in vertical and horizontal direction. Okay. The water is passing first in the horizontal direction and reaches the sand drain. Then it is moving to the upward direction. So that's why drainage is occurring in vertical direction and in horizontal direction. The next one is horizontal direction occurs due to the sand drains. As we place the sand drains, that's why the horizontal drainage is occurring. If you do not place any sand drains, the soil particle tries to move in the upward direction only. The sand drains accelerate the process of dissipation. Dissipation means removal of water. Okay. So this is the mechanism of compaction. The next one is what is the spacing of drains. Okay, we need to measure the spacing. So what is the distance between these two drains? These two drains. Okay, that should be less than the width of the medium. Okay, if we increase the spacing, then the water particle takes more time to reach the sand drains. Okay, which results in the failure of the sand drain. Why we are using the sand drain? To reduce the time of consolidation. So in order to reduce the time, we need to place the two sand drains very close to each other. Then the water particle easily, with no time, enter the sand drain. Okay, if you increase the spacing, then the water molecule takes more time to enter the sand drain. Next one, spacing is generally kept smaller than the width of the thickness in order to reduce the length of radial drainage path. Radial means nothing but horizontal. Okay, to reduce the horizontal length of the radial drainage path, we kept the smaller distance between the sand drains. Coming to the diameter, this is not a fixed value. General value of diameter of drain varies from 300 to 600 mm. Okay, based on the availability of casing diameter. Next one is too small diameters is not desirable. Why? Because of difficulties in filling the steel pipes. We need to pour the sand in a casing, that is hollow steel pipe, right? If its diameter is too small, we cannot pour the sand into it. So in order to overcome those difficulties, we cannot use the smaller diameter pipes. Okay. So let's summarize today's class. So what we learned today? The first one is what is meant by preloading and what is its purpose. Okay, what is a preloading and why we need to apply preloading. The second one is suitability. So for what type of soils this method is suitable? It is generally suitable for compressible soils, saturated clay and silt, and the third one is organic soils. Next, we learn about what are the advantages and disadvantages. Advantages of preloading and disadvantages of preloading. What are the disadvantages? The main disadvantage is it is a time consuming process. And the advantages are we are not applying any vibration forces and the cost is very less. And the next one is the implemented method of preloading is sand drains. Okay, it is just an implementation of preloading. Then what is the mechanism? How the consolidation is occurring? Mechanism. The next one is what is the spacing and what is the diameter of sand drains we need to provide. Spacing and diameter. Okay, in our class we discussed about all these 6 chapters. Okay, thank you.